Electronics.com. In this Arduino tutorial, we will learn how to use the DHT11 and DHT22 sensors for measuring temperature and humidity with the Arduino board. These sensors are very popular for electronic hobbies because they are very cheap but still providing great performance. Here are the main specifications and differences between these two sensors. The DHT22 is the more expensive version, which obviously has better specifications. Its temperature measuring range is from -40 to +125 degrees Celsius with 0.5 degrees accuracy, while the DHT11 temperature range is from 0 to 50 degrees Celsius with 2 degrees accuracy. Also, the DHT22 sensor has better humidity measuring range from 0 to 100% with 2 to 5% accuracy, while the DHT11 humidity range is from 20 to 80% with 5% accuracy. There are two specifications where the DHT11 is better than the DHT22. That's the sampling rate, which for the DHT11 is 1 Hz or 1 reading every second, while the DHT22 sampling rate is 0.5 Hz or 1 reading every 2 seconds. And also, the DHT11 has smaller body size. The operating voltage of both sensors is from 3 to 5 volts, while the maximum current used when measuring is 2.5 milliamps. Okay, now let's see how these sensors actually work. They consist of a humidity sensing component, a NTC temperature sensor or thermistor, and an IC on the back side of the sensor. For measuring humidity, they use the humidity sensing component, which has two electrodes with moisture holding substrate between them. So, as the humidity changes, the conductivity of the substrate changes or the resistance between the two electrodes changes. This change in resistance is measured and processed by the IC, which also makes it ready to be read by a microcontroller. On the other hand, for measuring temperature, these sensors use a NTC temperature sensor or a thermistor. A thermistor is actually a variable resistor that changes its resistance with the change of the temperature. These sensors are made by sintering of semiconductive materials such as ceramics or polymers in order to provide larger changes in the resistance with just small changes in the temperature. The term NTC means negative temperature coefficient, which means that the resistance decreases with the increase of the temperature. Okay, now let's connect the DHT22 sensor to the Arduino board. The sensor has 4 pins: VCC, ground, data pin, and a not connected pin which has no use. A pull-up resistor from 5K to 10K ohms is required to keep the data line high in order to enable the communication between the sensor and the Arduino board. There are some versions of these sensors that come with breakout boards with built-in pull-up resistors, and they have just 3 pins. The DHT sensors have their own single wire protocol used for transferring data. This protocol requires precise timing, and timing diagrams for getting the data from the sensors can be found from the datasheets of the sensors. However, we don't have to worry much about these timing diagrams because we will use the DHT library, which takes care of everything. Here's the Arduino source code. After we have included the library, which can be found from the Arduino official website, we need to define the pin number to which our sensor is connected and create the DHT object. In the setup section, we need to initiate the serial communication because we will use the serial monitor to print the results. Using the read22 function, we will read the data from the sensor and put the values of the temperature and the humidity into the T and H variables. If you use the DHT11 sensor, you will need to use the read11 function. At the end, we will print the temperature and the humidity values on the serial monitor. Here's the result that we will get after we will upload this code and run the serial monitor. I also made an example where I displayed the results on a LCD. You can find the source code of that example on my official website.